All right, everybody, welcome to the video here where we're going to go over the multiple choice questions on the August 2024 exam. We're going to take some time here to look through how we can answer some of these multiple choice questions using our calculator. And also, since we're reviewing, we might show some even using algebraic methods. So number one, as you read through this, there's usually one of these questions where they ask you what type of statistical study is being done. So just to go through the four choices before we actually look at the problem. A census is where we either poll or ask everybody in an entire population something. So it's not really looking at a sample, it's like a really huge group of people. An experiment is where we have two groups and we're testing for a causal relationship. So we're looking for an experimental group and a control group to see if there's any kind of a difference in the two groups. The other types of studies can have multiple groups, but there's no comparison happening. An experiment's going to have some kind of a comparison. And observational studies are about that. So in observational studies where we are observing results and then just looking at the data, right? You could be collecting the data from a website and just looking at it. We're not really doing anything to test for causation. A survey is where we're collecting data by asking a question. So those are kind of like the key things to look at, the four choices there. So in this scenario, we're talking about a grocery store. The employee stands in the store entrance for 2 hours and counts the number of people bringing reusable bags. There's no cause and effect here. Since they only did it for a couple hours, they're not looking at every single person, so it can't be a census. It can't be an experiment because there's not multiple groups where we're looking for causation. It's not a survey because the customer did not interact with anybody and ask them a question, so this is an observational study. Number two is asking about the graph of this exponential function. So let's take a look at it. So we have y equals 2 to the power of x, and we have minus 4. So this is our function. So they're asking us, when is the function positive? So when we are talking about a function's values, we're talking about the y values being positive, right? Where is the function above the x-axis? So it looks like it starts to touch the x-axis at 2, 0, and after the x value of 2, it's going to have positive y values. All of the x values that are smaller than 2 have negative x values. So we're talking about the interval from 2 to infinity. Remember, intervals are talking about the x values. What the function looks like over that interval is talking about the y values. Number 3 talks about this guy named Tim. He has $400 in a savings account, compounds monthly, and they even are so nice and they give you the compounding monthly plugged-in formula ready to go. Now, it wants us to know which one is equivalent to Tim's equation. So if we're talking about equivalent, we want to make sure that whatever we did to manipulate this equation would get us back to the original one. Another quick trick on multiple choice, if you see this word, you can graph the original function and your choices and just see which ones match. Now, if you do the 1 plus 0.027 over 12, just to see what that number is, that's going to come out to be 1.00225. So right away we know it can't be choice 2 because the base is not going to become less than 1. That would become a depreciation, not an appreciation problem. And then if you see this number, I then can look at choice 1 and say all they really did was they evaluated what was in this parenthesis and then they did exponent properties to undo the multiplication and made 12t and made it 12 to the power of t. So the answer here is actually choice 1. For the rest of the questions, like choice 3 here, only raises the exponent 12t to the 0.27 over 12, not the 1, so that can't be right. This is just wildly wrong. It's just taking the 12t and putting it on everything it possibly sees. We know that we can't do that algebraically. So that should be a pretty straightforward question to get that answer. Because again, you could just graph function A and each choice and see which one matches. For number 4, it says which equation is true for all values. Again, one of the ones where you could graph it. right? We can graph x to the fourth plus x, and then we can graph all the things that it potentially is equal to and see which one gives us the best graph. I want to show you that one for this one because there's a lot of algebra here that we potentially could do. So if I just graph one of the x to the fourth and the plus x, and then I can graph what it's equal to in choice 1, x plus 1 times x cubed minus x squared plus x. We can see that that gives us the same graph, right? So if we turn off 1, you can see it gives us the same graph. So this has to be the answer of choice 1. Just to show you what it would look like if it wasn't the right answer, like say we plugged in choice 2. Choice 2 says that we think it's equivalent to x plus 1 times x cubed plus x. We see that those are not the same graphs, so those are not equivalent. So although this was asking you to really factor, like the essence of this question was they wanted you to factor all of these expressions and see which ones can be manipulated, well, really you could have just done it on the calculator to get answer choice 1. Number 5 is a rational equation. So we have the first factor of this, so we would make this x plus 3, x minus 4, right, what multiplies to make negative 12 but adds to make negative 1. And then we want to create a common denominator, which is going to be any parenthesis we see. So x plus 1, x minus 4, plus x plus 3, x minus 4, and then equals x plus 3, x minus 4. Probably remember doing this in class. So now we have to ask ourselves what changed. So the first fraction only had x plus 3. So I have to put in x minus 4 in the numerator along with the x. The second equation only had the x minus 4, so I have to put a x plus 3 in the numerator along with the 2. The last fraction already had the common denominator, so it's just going to be 2x plus 27. From here, these numerators create your equation. So if we do some distributing, we get x squared minus 4x. We get plus 2x plus 3, not 36, equals 2x plus 27. Now from here, we see it as x squared in it, so we're instantly thinking it's quadratic, set it equal to 0. So if I subtract the 2x and the 27 to the other side, combined up some like terms, we get x squared minus 4x minus 21 equals 0. If this is one of the problems, it's going to come out to be factorable here, so think factoring. What multiplies to make negative 21, what adds to make negative 4 is negative 7 and positive 3. So our two potential answers are positive 7 and negative 3. You'll notice both of them are choices. And the reason why is one of these answers is going to be rejected because it's extraneous, and that one is negative 3. Not because it's negative, but because it would make this fraction's denominator 0. And we can't have 0 denominators, so this answer should be choice 4. Right? Again, we call that an extraneous solution. Number 6 tells us that we have these costs happening here. We have years since 1904. We have different fares on a New York City subway. And it says which equation best models this as a single ride fare based on the data. So you notice 2 of your choices are exponential, 1 choice is linear, 1 choice is logarithmic. Well, as you can look at the values here, the y values are increasing fairly rapidly. They're not increasing at a consistent space, so it's definitely not going to be a linear function. It's not going to be a logarithmic function because that would mean that it's increasing rapidly and then tapering off at the end. Well, that's not happening here, so it's got to be one of these 2. Chances are, if they're asking you to create a model from a set of data like this on this test, it's going to be exponential regression. So we have to use our regression technique here to get this value. So we have to put in some data. So we can create a table. And in X1, we're going to put in all of those years. So we're going to put in 0, 49, 72, 91, 99, and 11. And then if we look at our fares, we have 5 cents, 15 cents, 50 cents, $1.50, $2, and $2.75. Then you have your data. We're going to put in our Y1 squiggle. We'll put in our A times B to the power of X1. And we're not going to forget to click log mode. And then once we get log mode, we can see that that's clearly going to be answer choice 1. Number 7 is asking which is equivalent. So we see a polynomial being divided by another polynomial, and we instantly think, let's just jump right into some tabular division. However, for this question, if you notice something, it makes your life a lot easier. Notice every single remainder is different in the 4 choices. So instead of doing the whole division problem, we could just apply the remainder theorem. So the remainder theorem is asking ourselves, what in the divisor, what value of x would make that 0? And that's -2. Well, if I plug -2 into what I'm dividing by, whatever that answer is becomes my remainder. So if I do 6 times -2 to the 4th, plus 4 times -2 to the 3rd, plus -2, plus 200, whatever this comes out to be is my remainder. The remainder theorem is one of those things that is on the test every year at least 1 or 2 times, and sometimes it's hidden. Like, it doesn't say use the remainder theorem or find the remainder. It's kind of hidden within this problem, if you notice by looking at your choices, that all the remainders are different. So if you evaluate that and you get that value comes out to be 262. Which tells us it has to be whatever one has a remainder of 262. Now, if you want to go through the whole division, you could come up with this polynomial, this cubic number here, right? But you don't have to, right, if you know the remainder theorem. Number 8 is asking us to find the solution to this equation. So we see that it's exponential. We know we're going to have to use logs. If you look at your choices, we have some natural logs in there, which is interesting. So the first thing we're going to do here is divide both sides by 6. So we're going to get 2 to the x plus 4 is equal to 6. If we remember our rule here, we have a base, an exponent, and an answer. That's going to become an exponent is equal to the log of that same base of that same answer, same 3 parts. So we can rewrite this as x plus 4 is equal to log base 2 of 6. We then can subtract 4. And we get x equals log base 2 of 6 minus 4. Notice, not a choice. Now, there's a couple ways we can kind of get to this answer, right? The easiest and most efficient way would be just type this into your calculator, see what decimal you get, type in all your choices and see which decimal you get. You'll notice that 4 matches in decimal. Or you could have remembered one of your log rules, which is if you have a logarithm of any base, it becomes the natural log of whatever is in the parenthesis divided by the natural log of whatever the base was, and you could have gotten that answer as well. That was one of those real weird rules we maybe spent 10 minutes on in class and just moved on, because you can always get this answer by just finding the equivalent decimal. Number 9 is asking us for the asymptote line of the graph of the function f of x equals 5 log of x plus 4. First things first, if it's a logarithm, we know it's going to have a vertical asymptote line. So right away, test-taking skill here, we know that vertical lines have x equals equations, so this cannot be choice 1 or 4. So now I can graph this and see what it looks like and kind of identify where my asymptote line is. Although some of you might even know it just by looking at the function. So if we graph this, we put in our log base, which is underneath the calculus menu here in DESMOS. Let's see, where is it? Did I pass it? I did. log base A. And instead of, oh no, it's not log base. Let's start fresh. So we'll say y equals 5. This is a common log, so we don't need log base. We just need the one that says log without a base of any. All right, so we just hit log. Now we put in our x plus 4. So we can clearly see that the vertical asymptote is going to happen here at x equals -4. That's what this graph is approaching and never touching. Right? Remember, if you scroll down, eventually it might even say it touches there, but we know that it doesn't. It's just getting so close to -4, it eventually rounds it. So we know that this answer is choice 2. We also could have gotten that by taking whatever's in this parenthesis and setting it equal to 0. We could have solved it that way. That is always going to give us our vertical asymptote. Number 10 is a probability question. So it tells us the probability of doing math homework is 1/3. The probability of having English homework is 1/7. So we know a couple probabilities already. We'll just use M for math, just so we can stay organized, and E for English. It then says the probability of having one or the other is 9/21. So the probability of math or English homework is 9 out of 21. And we want to know the probability of getting both. Well, to get both, we need to figure out a rule. One of our probability rules is 4 is equal to the probability of the first event plus the probability of the second event minus the probability of them both happening, the end event. So we plug in what we know, 9 out of 21 equals 1/3 plus 1/7 minus, I'm just going to use x to represent n, so it makes it a little bit easier to do the algebra. So if we add together 1/3 and 1/7, 1/3 and 1/7 is going to become 10/21 minus x. You could just add it in your calculator and change it to a fraction. We then can subtract 10/21 to both sides. Again, you could do this subtraction in your calculator if you're not great with fractions. We get -1/10 is equal to -x, which means our answer should be, not 1/10, 1/21. There we go. Our answer should be 1/21. For number 11, I would not do any algebra here. You can square both sides, you can do all the factoring and get to an answer. I would just graph this. Because it's in equals, and we were just looking for the solution, we just want to see where these two graphs intersect. The graph of y equals x minus 1, the left side of the equation, and the graph y equals the square root of 2x plus 6. I can see right away they intersect at the x value of 5, so the answer is just 5. Number 12 was a tough one. You really needed to know your exponent properties to do this one. I know it says equivalent, and a lot of times they'll say if it's equivalent, you can just graph and then look for the ones that match. This x is greater than 0 thing makes that a little bit tough to do, so I'm just going to do the algebra. So the first thing I would do is change what's in the parenthesis to x to the positive 2. Remember, when you have a negative exponent, it acts like it's a reciprocal. Then I'm going to use the power to power rule to multiply those two together. So I have x to the 6/4, which reduces to x to the -3/2. So right away, as soon as I'm there, I know it cannot be choice 1 or 3. Because I know this is eventually going to become a fraction of 1 over x to the 3/2. So now I need to ask myself, is this equivalent to choice 2 or 3? Well, x to the 3/2 is a square root of x cubed. Right, remember it's exponent over root. Well, that kind of eliminates choice 4, leaving me with the only option left, which is choice 2. Now you might be saying, well, that's not the same as 1 over the square root of x cubed. However, it is, if you simplify that, it's x squared times x, which becomes 1 over x, because the square root of x squared is x, times the square root of x. Number 13 asks which one has a period of 3. So as soon as we see a sinusoidal function and we're talking about period or frequency, we have to remember our rule, which is period times frequency equals 2 pi. You can adjust this rule, and you can say, well, we know that the period is equal to 2 pi over the frequency by just doing some algebra. We can also say the frequency is equal to 2 pi over the period by doing some algebra, just dividing either p or b to the other side. Since I know the period is 3, I'm going to use this one, because I can say the b has to be 2 pi over 3 for this to work. Then I'm going to look at my functions and say which one has a b value of 2 pi over 3, and that would be choice 1. Number 14 asks us for a 4th degree polynomial. As soon as I see 4th degree, it's an even degree, so it's either up, up, or it's going to be down, down. The next piece of information says it's a positive leading coefficient, which means it's not down, down, meaning it can't be choice 3 or 4. The next piece of information tells you the answer. It tells us it has 2 real zeros, meaning it's going to intersect the x-axis twice, and 2 non-real zeros, which means those are going to be imaginary, and they're not going to be x-intercepts, leaving us with choice 1. Number 15 has us doing some algebra here with I. Remember, I squared, the imaginary unit squared, is always -1. That's probably going to come up here, but let's see. So if I do some distributing, I'm going to get 10xi plus 15, there it is, I squared, minus the square root of -9 is going to become I square root of 9, and we know the square root of 9 is 3, so that's equivalent to just 3i, times that by x, and we get 3xi. Now, to simplify this, we're going to simplify I squared by saying I squared is -1, and -1 times positive 15 gives us -15. I'm going to put that first because I look at all my choices and they're in a plus bi form. Then I'm going to combine my like terms here of 10 and -3 to get positive 7xi, and this is my answer nicely in a plus bi form. Number 16 asks me to find the focus of a parabola. So to find the focus of the parabola, we have to first put it in the right form. So I'm going to divide both sides by 8. I'm going to get y plus 2 equals, I don't like divide by 8, I'm going to put times by 1/8 so it looks how I want it to look. I'm then going to subtract 2 to the other side, and I'm going to get my nice quadratic equation here in the form that we like. The reason why we like this form is it's called vertex form, so I should be able to easily identify the vertex. The vertex is going to be -5, opposite of whatever is in the parenthesis, comma, -2, whatever is outside the parenthesis. Now, from the vertex, we have to decide, is our parabola opening up or down? And that's going to be based on the leading coefficient, 1/8. So we now know that this parabola opens up. So when we're drawing our parabola, remember all of these we drew sketches. So we have a focus that's being hugged by the parabola, we have a vertex, and then we have this thing called the directrix down here. If it's an open up parabola, all this would be upside down if it opened down, if that 1/8 was negative. Now, since we know the coordinate of the vertex is -5, 2, to get this distance from vertex to focus, it's always whatever is down here is equal to 4p. P is 2, meaning this distance is 2. So if you visually count from -5, -2, and I go up 2 units, I would be at -5, 0. That's going to be the equation or the coordinate of our focus. If I wanted to find the equation of the directrix, I would go opposite of that. So instead of counting up 2, I would count down 2. So I'd be at this point here of -5, -4, and I'm going to ask myself what equation of a line would pass through that point, which would be y equals -4. Number 17 is just a straight up graphing question. It wants a solution, it gives us two different equations, and it's asking us for when they are equal to each other. So all we have to do is graph both of these. So I'm going to graph both of these functions. Let's see, so we'll call 1y equals, you can name them q of x and r of x if you really want to, it shouldn't matter here. So if we go through here and we put in our log, right, common log again of x, and we'll graph the other equation, which is y equals, let's see, x minus 2 squared minus 4. So we have one solution, we have two solutions. Remember, when we're talking about solutions, we are talking about the x values. So one of those x values, did I plug something in wrong here? Oh, it's cubed, not squared. I saw none of those answers. So let's see. All right, so we have an x solution here at 3.7, which is our answer, choice 2. Looks like we have another solution down here someplace. It's at 0, which isn't a choice. So we have 3.7 in the logical answer for number 17. For number 18, they give us this big paragraph to read through about links and things in the box, and it wants us to find volume. So it tells us that the height is x, it says the length is 18 minus 2x, and the width is 18 minus 2x as well. So to find volume, we're going to multiply length times width times height. I'm just going to put the height first because it's x by itself, times 18 minus 2x times 18 minus 2x. And then from here, we're trying to figure out which of these is equivalent to this product. Well, again, we can use our calculator to graph that and then graph all of our choices and see which one matches. Or, since we're reviewing and we're practicing our algebra skills here, we can multiply 18 minus 2x times 18 minus 2x. We get 324. We'd get negative 36x. We'd get negative 36x. And we get positive 4x squared. So we can say v of x is equal to x times, I'm just going to put it in the right order, 4x squared minus 72x plus 324. From there, I can just distribute the x, basically increasing every x exponent in my equation there, and I can see that my answer should be choice 2. The next one is asking us again to use exponent properties, so we see the same base. So when we're multiplying things with the same base, we're going to add the exponents. So I'm going to say x over 2 plus x over 3. Well, to add these, we need to make a common denominator, so I want to make them both 6. To do that, I would have to multiply this first fraction by 3, so that would make this 3x. The second fraction I'd have to multiply by 2, so that would make that 2x. So in total, this is 5x over 6. That's just adding the exponents together. So what we really have is we have 8 to the 5x over 6. Well, using our property of exponent over root, I can say this is the 6th root of 8 to the 5x. And then look for that answer. It's choice 1. And we move on. Number 20 tells us that we have an angle in standard position. It tells us that angle has a point that passes through at negative 3, negative 4. This is in quadrant 1, 2, 3. So now we have to figure out, what do we know about quadrant 3? In quadrant 3, we know that tangent is positive, meaning cotangent is positive. Since we're moving to the left and down, we know sine is negative. We also know that its reciprocal cosecant is negative. We know cosine is also negative, and its reciprocal secant is also negative. We remember that because the point on the unit circle, the x-coordinate represents cosine. The y-coordinate represents sine, so if the point has a negative x and a negative y, even if it's not on the unit circle, it's an extension of the unit circle, it's telling us where everything is positive and negative. So now I just have to find the right choice. So greater than 0 is positive, less than 0 is negative. So the only choice here that makes sense is choice 4, where secant's negative, we know that, where tangent's positive, we know that that's true. All the other choices are false. Number 21. We love seeing the 3x3 system as a multiple choice and not a free response, because we can just graph this and find this answer without having to do all of that crazy algebra. So let's go to our calculator here and graph this. So when we're solving one of these 3x3 systems on our calculator, we're going to need to do something a little bit different since there's 3 variables. So we're going to add 4y, we're going to subtract 5, and we'll put in z, and then say it's equal to negative 27. It's going to ask you to add a slider. You can go ahead and add it. Then we're going to type in the next 2 equations. It should not ask you to add any more sliders because we've already added one for that variable z. Negative 3, let's see. All right, and then the last one, we have 6x minus y plus 4z is equal to 3. So our job now, right, our job now is to get it so that all 3 of these equations intersect at the same location. So I want to adjust my z value. So I'm going to adjust my z value here until we get something where they all intersect at the same place. And we've done that. So that x value of negative 3 is the x value to this solution of the system. That y value positive 3 is the y value of the solution. And the z, which is on our slider, should be 6. So that's how we can check a free response system, or for this multiple choice question, just say, they want to know y is 3, we're done. Number 22 wants us to know if these 2 events, working nights or working weekends, are independent, and then also how did we prove that they were independent. So a good test taker is going to look at this and say, well, it can't be choice 2, because if they were independent, this would be true, it wouldn't be not true. And it can't be choice 3, because if they weren't independent, that can't be true, right? So only 1 and 4 are potential answers here based on what we know about probability. Now, if you do some quick calculations here, you can see that there are 20 total people that work nights, there are 100 total people that don't work nights, there are 48 total people that work weekends, and 72 total people that do not work weekends, for an overall total of 120. So if we find some probabilities, the probability of working nights, well, there are 20 people out of 120 that work nights. The probability of working weekends, well, working weekends, there are 48 people out of 120. And the probability of both, well, that would be the people that work weekends and work nights. That would be 8 people out of 120. If we solve the left side of this and the right side of this, they both come out to be the same number. So if I take my fractions here, I know we all love our fractions. So if I take 20 divided by 120, and I multiply that to 48 out of 120, I get that decimal. And if I take 8 out of 120, I notice I get the same decimal. So because these 2 things are equal to each other, I know that these are independent events, because that rule only works for independent events. Number 23 is another one of those equivalent ones. You can graph the original and then graph all 4 choices and see which one matches in graph. However, the essence of this question is, can you do difference of 2 squares? So if we wanted to do difference of 2 squares here, we'd have to say, well, we have x to the 4th plus y to the 4th, x to the 4th minus y to the 4th. Remember, it's always plus and minus, and then we're just essentially taking the square root of each part, right, or halving the exponent. We know that we can't factor this first one because it's a sum of 2 squares, so we're just going to leave that. right? We can't factor that unless we use imaginary numbers, and I don't see that anywhere here. The second expression, though, is still factorable because it's still a difference, and it's still perfect squares. So we can chop those exponents in half again. And then I can do that even one more time to this last expression to get x plus y, x minus y. I'm not going to rewrite these first two again. They're the same thing. And we can clearly see its choice. The last one asks us about a assistant. First year salary $90,000, and every year their salary goes up by 2% for the first 10 years of employment. And here is your key word. They want to know in total. They want the sum of the first 10 years of employment. So if you're making $90,000 every year for 10 years, you know that this answer has to be bigger than $90,000, even $100,000. It can't be those two choices. To be honest, without even doing the math, I know it's going to be choice 4. Because $90,000 times 10 is $900,000. So we know that this answer has to be more than that because it has to take into consideration the increase in pay every year by 2%. To show the math, like where it actually came from, we're using the geometric series formula, which is on your reference table. So it's a sub 1 minus a sub 1 times r to the number of years in this case, and then divided by 1 minus r. Well, we know the first value is 90,000. The rate is 1.02. The reason why it's 1.02 is we need to increase each year. So like year 1 is 90K, year 2 would be $90,000 times 1.02. That's how I get the next salary, right? And then we do that for 10 years. And then divide that by 1 minus 1.02, and that's going to give us our 985,475 number. It's probably rounded here, but that's close enough. Hopefully this video helped you make sense out of some of those multiple choice questions you might have missed or were unsure how to start or do. And good luck with all of your studying.